Hello, audiences and judge, and welcome to our presentation. There are 5 members in our team. That's me, Hiếu, Nam Phương, Minh Tú, Kiệt, and Hải. And due to the outbreak of the COVID-19 and the lockdown situation in Vietnam, we are unable to gather as a group. And so this is our best option. So today, we proudly present to you our project called the IoT wristband for health and positioning monitoring. It is undeniable that the COVID pandemic has swept the world and created a big hit to the medical shield. It is causing shortages in the global personal protective equipment and personal medical supplies. First, healthcare workers are burned out and exhausted, but are unable to stop the spread of the coronavirus.
So, based on problems that we mentioned before, we have been coming up with modern and effective ideas to solve the issues. Our device should serve 3 main functions. First, it must be a compact, wearable device that can monitor users' health conditions and keep track of their position continuously. Next, all the recorded data will be uploaded to an online server. And last but not least, users cannot remove the device unless they are approved. Moving into the implementation process, which is really simple. To begin with, we listed out all the requirements such as stable connection, energy saving, and compactness. Next, we had to draw out the schematic and design the case for the device. The process continued with testing out all the components on the breadboard. And finally, when the device is finished, it is to roughly test it before going into operation.
We will now move on to the components. We've included 2 sensors in our device to monitor users' health. First is the FAS30100. It's an intuitive pulse oximeter and heart rate monitor sensor solution. It combines 2 LEDs, a photo detector, optimized optics, and low-noise analog signal processing to detect pulse oximetry and heart rate signals. This module is widely used in wearable devices, fitness assistant devices, and medical monitoring devices because of its precision. Next is the GY906 temperature sensor. It's a small-sized, non-contact infrared thermometer for use with any microcontroller that can communicate with through its I2C interface. This module has a wide temperature range from -70 to 380 Celsius degrees for the temperature of the objects, as measurement resolution is not that of 2 Celsius degrees. For tracking position, we use the A9G GPS tracker module. It's best suited for real IoT projects which require outdoor monitoring, long-distance monitoring, and GPS tracker. So it will be ideal for us to use this module for locating our patients' positions. All of the information collected from these sensors will be directed to the Arduino Nano, which is the brain of our system. The Arduino Nano will receive the signals from these sensors before converting them into understandable scales. Then all the processed data will be sent to 2 places. First, the information can be displayed on an OLED screen in the system, which allows users to keep up with the data. Secondly, in order to fulfill remote monitoring objectives, it will be sent via radio frequency signal and Wi-Fi, which require both stability and long-range transmission. This procedure begins with an RF module attached to the device that serves as a transmitter. The data from the transmitter is received by another RF module, which in this case is the receiver, then sent to an ESP8266 Wi-Fi module. By uploading all received data to an online server, this Wi-Fi module completes the whole process.
Hello, my name is Hải, and today I will talk about the results and the innovation that comes from this project. First of all, the results. As a result, this would end us with a small device that would allow both healthcare workers and patients to monitor their health statuses. This device also has an extra feature, which is monitoring ambient temperature and humidity constantly. Moreover, we highly prioritize efficiency and the reliability of our system and still ensure its compactness and aesthetics. Through many field tests, the whole system can be adapted and improved based on ongoing problems. By monitoring people's health conditions and position 24/7 without direct supervision, chances of detecting infected people greatly increases. Hospitals will be less crowded as this device keeps track of personal records and uploads them to the main server, which can be accessed by hospitals at any time. Plus, if the wristband were to achieve widespread use, it could help to save a lot of money spent on paying healthcare workers' wages.
Optimization. Although this project seems already well fleshed out, there can still be room for improvement. First, an application can be developed for both healthcare workers and patients to track data. The user can connect their wristband to the application, and the app will receive data for vital signs from the patient. This app should be available on both Android and iOS platforms. Next, we're planning to integrate near-field technology, or NFC technology. The idea is to assign each wristband to an identification number and make the device scannable. This NFC technology could prevent sabotage so that wearers cannot remove the device without given permission. If they try to remove it, however, the device will send an alert to the control unit and notify healthcare workers. When permission is given, they can scan their wristband at the nearest control unit and be let free. The device will be unlocked automatically if the NFC tag matches that of the ID in the NFC reader. So far, we have only proposed possible software refinements, so we shall head into hardware improvements. First, an upgrade on the plastic cover. Now, the sole reason why we chose plastic as an exterior is to reduce production costs as to make it viable for public use. But still, of course, the plastic will still have to withstand adequate pressure and impact as to avoid damage to the electronic components inside. And finally, improvements to the comfortableness of the wristband. We must take into consideration that this product will be worn by patients 24/7, and any amount of discomfort will prove annoying over time. We could add some foam or soft material around the wrist so that it would be more comfortable to wear, and maybe better ventilation so that sweat would not build up around the wrist. And that was the end of our presentation. We hope you liked our idea, and thank you for listening.